Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem solving questions. It has 174 data sufficiency questions. We have solved already all of these problems. If you're interested in watching this original solution to any of these problems, you will find the original solutions from day number 1 through 250. Right now we are in the process of redoing the problems, and we are on page number 279. Please turn to it, page number 279, the very first problem on the page, problem number 45. Problem number 45, we are given a table there which I'm going to reproduce here. We have 4 cities, R, S, T and U, we are told. R, S, T and U. R, S, T and U. And it shows the distance between the two cities. Because of the fact that it's showing the distance between the two cities, then obviously the distance from R to R is going to be silly, it's going to be 0. These cells are going to be blank. The vertical, the diagonal cells are going to be blank. And here are the entries that is given to us. We are told that this is Y, this is X, this is 62, this is 75, 56 and 69. The question simply is, what is the most direct route between, let's see, it says, well, it just simply says what's the value of X. They're looking for X here. How much is X? That's the question. When X, of course, as we can see, is the distance from T to R. They're looking for T to R. We're looking for this distance, R to T or T to R. Let's see what they tell us in the first statement. In the first statement, they tell us that S to T is twice S to R. S to T is twice S to R. S to T, let's see where S to T would be. Town S to town T. 56, we are told, is equal to 2 times S to R. I hope that you realize right now that we are wasting our time here. S to R is Y. Because as you can see, we are interested in distance from T to R. This thing makes no mention of T to R. All we know now is the value of Y. We can solve for the value of Y. We can figure out the distance from R to S, but it's not going to help us figure out the value from T to R. Statement number 1 is not useful. Statement number 1 by itself is not sufficient. A, D, B, C, E. As a matter of fact, it's not only that it's not sufficient by itself, but putting it together with the second statement, regardless of what the second statement says, is also it's not going to do any good because it's actually worthless. It doesn't tell us anything at all that we need to know, which is the distance from T to R. Answer cannot be A or D. Let's look at second statement. The second statement tells us that the distance from T to U is equal to 1.5 times the distance from R to T. Let's see what that tells us. T to U, where is T to U? Here is your T, here is your U. This cell is what we're looking for. This cell here, this cell right here, T to U. This cell right here is the mirror image of this cell, 69. You see, U to T. 69 is equal to, this is going to bother me, 69 is equal to 1.5 times R to T. What is R to T? R over, there you go, X. Voila. Now we know that X equals 69 divided by 1.5. We can figure out the value of X. Second statement by itself does the job nicely. The answer is B. Second statement by itself does the job nicely. Now you don't actually have to solve the value. You don't have to actually waste your time trying to figure out the value of X. Nobody's asking us for that. We're just going to do it right now for the learning purposes, not for the exam. So this tells us that 69 is equal to 3/2 of X, and therefore X is equal to 69 times 2 over 3. Divide top and bottom by 3, we get 23. 23 times 2. Turns out X is 46. But that was not necessary. Let's move on to the next question, shall we? Problem number, well, I didn't even put down the number here. This was number 45. Let's move on to the next one, shall we? Number 46. Give me a second. Number 46. In number 46, question is, what's the 10th digit? What is the 10th digit of a number? So we have a number and we do not know what it is, obviously. Question is, what's the 10th digit of it? Let's see what they tell us. Now, before we actually go into looking at the two statements, I want to make sure that you understand the concept 10th digit. Sometimes I come across people who have forgotten these concepts. So I'm going to take 2 seconds to actually cover this concept of 10th digit. For example, if you have something like this, 5, 6, 7, 8, 9, here something like this, 567.89, this is called the 10th digit. 10th with a th at the end. This is your not hundred, but 100th digit. This is what is known as the unit digit. This is your 10 digit, and finally this is your 100 digit. It is called the 100 digit because this digit tells us how many hundreds we have. This is called the 10 digit because this tells us how many tens we have. In 567 we have 500, 6 tens and 7 ones. It's also sometimes called ones digit or unit digit. This is what we're trying to figure out. The question is, we have a number here. The question is, what is the 10th digit of that number? Let's see what they tell us, shall we? Obviously they have to tell us something, otherwise we're not going to get anywhere. Statement number 1 tells us that n is less than 1/3. Well, simply knowing that it is less than 1/3, this number in question is less than 1/3, it's not going to enable us to figure out what is 10th digit. It could be anything. The statement by itself is not enough. A, D, B, C, E. The first statement by itself, of course, is not enough. The answer cannot be A or D. Let's look at second statement. Second statement tells us that this number that we have is something more than a quarter. Again, simply knowing that it is more than a quarter is not going to enable us to ascertain the 10th digit of the number. This by itself is no good. Answer cannot be B. Let's put them together, shall we? If we put them together, what we find is that we have this number n, and now we know that whatever it is more than 1/4. We know that it's more than 1/4, and we also know that it's less than 1/3. The first statement tells us that it is less than a third, the second one tells us it's more than a quarter. So now we know that whatever it is, it falls between 0.25 and 0.33. Can we figure out what the 10th digit is? Well, obviously not. For all we know, n that we're looking for, it could be 0.26 or 0.27 or 0.31 or 0.32. Or it could be anything. There are infinite number of possibilities. But that's not the point. The point here is that we do not know what the 10th digit is. The 10th digit could very well be 2 if it happens to be 0.26, or the 10th digit could very well be 3 if it happens to be 0.31 or 0.3125 or 0.3137. There are infinite possibilities. But the point here is that the 10th digit could be either 2 or 3. Putting the two statements together also did not get us anywhere. The answer is E. The answer is E. Let's move on to the next one, number 47. Number 47. Let's see what's going on in 47. In 47, we have 3 robots. We have 3 robots, X, Y, and Z. We are told that R with the subscript X represents the ratio of their speeds. The ratio of the speed of robot X to the robot Z. Let me erase one of this thing, it's getting in the way. I want to make sure that you understand the notation here. I want to make sure that you understand the notations here. The capital X, Y, and Z are the names of the robots. These are the names of the robot. X, Y, and Z, the small letter X, Y, and Z are the speed, are their the speed, how fast they work. And we are told that Rx, capital letter R with subscript X is equal to the ratio of robot X to robot Z, their speed. We are also told that Ry, R with the subscript Y, is the ratio of Y to Z. And the question is robot Z the fastest one? The question that they're asking here is that, is robot Z, is this guy the fastest robot do we have, is the fastest robot we have among the three that are mentioned here? Well, let's find out, shall we? Let's see what they tell us. Now, asking us, is robot Z the fastest robot that we have, is the same as asking, is Z the greatest? Because you see, X, Y, and Z are their speed. So Z represents the speed of robot Z, small letter Z represents the speed of the robot Z, and the question here is this value the greatest among the three values? Let's see what they tell us. I need the room, and I have used up all the room on the blackboard here, so I'm going to have to erase something. I'm sorry about it, but as they say, c'est la vie. I don't want to start at the bottom here. Let's see what they tell us in the first statement. In the first statement, they tell us that Rx is less than Ry. Well, let's see what we can do. Remember, these are their speed. The small letters are their speed. Rx, as we know, is the ratio of X to Z, which we are told is less than this ratio. Now, because of the fact that X, Y, and Z are their speed, as we already mentioned, therefore they are all positive. These are all positive values because there's the speed of the robots. And because X, Y, and Z are all positive, what we are interested in is in the fact that Z is some positive number. Because it's a positive number, we can multiply both sides of this inequality by Z without having to worry about switching the direction of the inequality. The direction of the inequality will stay the same if we multiply it by a positive number. So let's do that. We cross it out, and what we get here is that X is less than Y. What the first statement tells us is that the robot X is slower than robot Y, but it tells us nothing at all about robot Z, and we are interested in knowing if the robot Z is the fastest one. Statement number 1 by itself is not sufficient. A, D, B, C, E. Statement number 1 by itself is not sufficient. The answer cannot be A or D. Let's look at second statement. In the second statement, they tell us that this ratio of R to Y is less than 1. Let's see where that gets us. R to Y, if you remember, is the ratio of X to Z, which is less than 1. Again, because of the fact that Z is positive, we just established here, we can multiply both sides by Z, get rid of Z, and this tells us that Y is less than Z. What the second statement tells us is that robot Y is slower than robot Z. Well, if robot Y is slower than robot Z, that does not necessarily mean that Z is the fastest one, because the second statement makes no mention of robot X. Second statement by itself is also no good. Answer cannot be B. Once we put them together, let's do it here. Once we put them together, then of course we get somewhere, because the first statement tells us that X is less than Y. We're told that X is less than Y, and the second statement tells us that Y is less than Z. I don't know if you can actually read that low or not. Once we put them together, we know that first statement tells us that X is less than Y, and the second statement tells us that Y is less than Z. So together it implies that X is less than Y and Y is less than Z. If that's the case, then Z would have to be the fastest robot among the three. Hence, putting the two statements together does enable us to answer the question, is robot Z the fastest one? It turns out it is. Even if the answer turned out to be no, if we had found out that robot Z is in fact the slowest robot, or somewhere in the middle, it still would have been enough. We just have to be able to give an answer, definitive answer, either in affirmative or negative. Here, it's just a fluke that it turns out to be affirmative. Robot Z is in fact the fastest robot. The answer is C. Putting the two statements together does the job beautifully. Let's go to the next one. That was question number 47. Number 48. Number 48 tells us that x is somewhere between a and b. We are told that y is somewhere between c and d. Y is somewhere between c and d. And x is somewhere between a and b. The question is x less than y? Let's find out, shall we? Is x less than y? Let's see what they tell us. Statement number 1 tells us that a is less than c. Well, what this tells us is that a is less than c. What they tell us is that the lower limit of x is less than the lower limit of y. Is that enough for us to be able to tell if x is less than y? The answer is no. For example, this is the situation that we have at our hand. Maybe what we are looking at is here 2, 3 and 4. X is 3, which is it lies between 2 and 4, and y happens to be 4, 5 and 6. Well, in which case is x less than y? The answer is yes. X is 3 and y is 5. As long as a, which is 2, is less than 4. You see, the lower limit of x is less than the lower limit of y. I'm making too much fuss about it. I know that I want to finish it up. I want to wrap it up. But it could also be 2, 3 million and 4 million. So now x is 3 million and y is still 5. Y is still 5, and now x is more than y. Knowing the lower limit doesn't do anything. Knowing the lower limit does not do anything. The first statement by itself is no good. A, D, B, C, E. Answer cannot be A or D. Let's look at second statement. The second statement tells us that B is less than C. Aha! B is less than C. Now we are getting someplace. What does B represent? What does B represent? B represents the upper limit on x. So now we know that upper limit of x, we are told, is less than C, which represents the lower limit on y. The lower limit on y. Well, there you go then. If the highest value that x can be, listen carefully, if the highest value that x can be, which is b, if the highest value that x can be is still lower than the lowest value that c can be, one more time, if the highest value that b can take is still less than the lowest value that y can take, then x would have to be less than y. That's all. Maybe the highest value that x can take is 100 and the lowest value that y can take is 101. Then obviously, regardless of what x is, obviously it's less than y, because even if x happens to be 99.99999, if x happens to be 100 asymptotically, it's still less than the lower limit of y. Second statement does the job beautifully. Therefore the answer is B. Let's move on then. Next one, number 48. Give me a break one more time. Number 49. Number 49. How many are directors of both company K and R? I do not know what's wrong with these markers. I just opened them. They are brand new and yet they don't work. It's a sheer waste of money. Let's see what they tell us. So our job is to figure out how many of the directors belong to both company R and company K. Let's see what they tell us. The statement number 1 tells us that 17 were present. We are told that we are having a meeting of the directors, and in the meeting 17 directors were present. We are also told that none was absent. None was absent. Alright. does that tell us? So 17s are present, nobody is absent. That only tells us that there are a total of 17 directors. There are a total of 17 directors, but it does not enable us to tell us, it does not enable us to ascertain how many belong to both company. How many people, how many of these directors? We know there are 17 altogether. We know that the total number of directors, what the first statement tells us is that there has to be the total number of directors in both companies 17, because that's how many people there were in the meeting. We held the meeting of the directors of company K and company R. 17 people showed up and nobody was absent. Well, if nobody was absent, then there are altogether 17 directors in both companies. But that does not enable us to tell how many belong to both company K and R. Perhaps there are some people who are directors of both companies. Or perhaps there is nobody is like that. We do not know, we cannot tell. The first statement by itself is not enough. A, D, B, C, E. A, D, B, C, E. Because of the fact that the first statement we just found out is not sufficient, we know now, answer cannot be A or D. Let's look at second statement. Second statement tells us that K has 12 and R has 8. K has 12 and R has 8. Again, that by itself does not tell us how many belong to both companies. How many people are directors of both company K and R. We know that company K has 12 directors, we know company R has 8 directors, but that by itself does not enable us to ascertain how many are directors of both companies. Second statement by itself is also no good. Answer cannot be B. But if they put them together, then of course it's quite obvious, because altogether we have 20 here. We have 20 here, and yet we are told that 17s were present in the meeting. Well, if the 17s were total people who were present in the meeting and no one was absent, and if you add them up individually, 12 and 8, that's 20, then there must be 3 people who belong to both companies, who are directors of both companies. And if you like, you can very quickly show it with the Venn diagram. Here's your Venn diagram. Here's your company K, and here's your company R. This part tells us there are 12 people in here. This part tells us there are 8 people in company R. But we are told that there are 17 altogether. 12 plus 8 is 20. There must be 3 people. There must be 3 people who belong to both company R and K. So once we put 3 here, we have to go back and adjust this figure. So 12 becomes 9 and 8 becomes 5. There are 5 people who are directors of only company R. There are 9 people who are directors of only company K. And there are 3 people who have the directorship of both company K and R. Putting the two statements together does the job nicely, does the job beautifully. The answer is C. That was it. That was the end of the last question in the first column. I'm not going to start a second column right now because it gets to be too long, the video. We'll do the second column tomorrow, okay? Bye now.